Okay, if you happen to be absent for some reason from school, there is a series of classes you can attend on Google Live. Mine happens to be this class period, period 4. So at 10:44, I'm supposed to log in and start my live classroom, which I have. I've got it open and I've got it running. And you can see that I've got the meeting going. Okay? So in order for you to do it at home, though, I'm going to show you how to get there. You'll go to your classroom in Google, and you want to find the live classes. Sit down. You want to find the live classes. Mrs. Mueller, Mrs. Frandsen, Mrs. Lewis, and Mrs. Mackey. Each of us have a live classroom. You're going to that live classroom, and then you're clicking here. Once you click there, it will let you into this live classroom, and you can see and hear what's being done on the smart board and in class, okay, through that class period. I do not record mine, okay? I usually put recordings in your classroom. Like if there was a recording for you to watch, there would be a little video thing here. So if you needed to watch a video, you can click there, and it's just doesn't seem like it helps if I record my live classes because I'm always doing stuff at the board with you guys. They're always, a lot of times, standing at the board, making a lot of noise and really following along in class is hard. Okay, except for like days like today when we're taking notes. So another thing I want you to notice too, in each one of our classes, at the very top, I have access your math book online. This is a video that tells you how to get into your math book online without your username and password. So should you forget your math book, or the dog ate your math book, or you have a homework assignment and you have no access to a math book, there's no excuse for you not to do your work. Look at this video, figure out how to jump online to get your questions. Okay, so that is that. That's how we log into our live classroom to get our math done each day. We are today going to review a few things. We're going to start with reviewing factor trees. So let me get to the starting of this. I don't know why I did this way. Here, let's go this way. And I'll slide up here. There we go. Boom. Okay. Prime factorization. All of us know what this is, right? Yeah. Let's refresh our memory. The chemistry of mathematics is in prime factorization. Every number has its own unique prime factorization, and this is a cool thing, trust me. It makes fractions a breeze. What is a factor tree? A factor tree is a graphic organizer to help us find the prime factorization of any number using factor pairs. What are factor pairs? They're sets of two non-zero numbers whose product result in a definite number. That means that if there's a number sentence that results in a product, the two numbers here are the factor pairs in that number sentence. The numbers you're multiplying together. Okay, the 9 is a factor, the 7 is a factor. Both are a factor pair of 63. Okay, and the word product here simply means a fancy way to say answer to multiplication question. Okay, so 63 is a composite number because it has more than one factor pair. 9 times 7 equals 63, but also 1 times 63, 3 times 21, and then that 9 times 7. You can list the factor pairs in order from least to greatest. Okay. Then you can use the factor pairs to start a factor tree, except never use 1 times 63. Never use a 1 in your factor tree. Ever. Okay. Mrs. Frandsen, why not? Because 1 is neither prime nor composite, and we're looking for the prime factorization of the number. That's why we never put 1s in our factor trees. Okay, to do a factor tree, you start with the number at top, you give it branches. You pick any factor pair, and then ask, are they prime? Well, 7 is, so I circled it, but 9 is not. And when we're done, we have the prime factorization for that number. Just like you'd have, if you have 2 hydrogens and 1 oxygen, you have H2O. That's the makeup of water. That's the molecular makeup of water. This is how we make a 63 with prime factors. It's the unique set of prime numbers that, when put together through multiplication, gives us 63. So what number is forbidden in a factor tree, everybody?
1.
1. The number 1 is forbidden in a factor tree. This is a quote from Mrs. Frandsen.
Whoa, this painful.
It is. So you have to start a factor tree with one of the numbers that is composite. Prime numbers don't work in factor trees. And then pick a factor pair that you know makes that number and keep going until you know all those numbers are prime. The prime factorization for 23 is 2 times 2 times 2 times 3. I meant 24, sorry. Can we use a different factor pair and still get the same answer? Yes. Still, it's 2 times 2 times 2 times 3, even though we started with a different set of numbers. 24 again, another set of numbers, another factor pair. And the same exact prime factorization. As long as you do it accurately, no matter what, that number, that composite number, will always have the same prime factorization no matter which factor pair you start with. Okay, that's our review of those. Okay, now we're going to review greatest common factor, but we're skipping past the factors, the Venn diagrams. Okay. So this is really quick and painless. Sit still, please. If you have 64 and 124, what's the greatest common factor? Well, one way to find out is to write a list. The other way to find out is to make factor trees. Okay, here's the factor tree method. Find all the prime numbers that build 64. Well, it's 2 times 2 times 2 times 2 times 2 times 2. The factor list for our prime factorization of 124 is 2 times 2 times 31. And then find out what they both have at least one of. They both have at least 1 2. They both have at least 2 2s. So our prime factorization tells us that 4 is our greatest common factor. Okay, you multiply them back together. Here's the list version. Here are all the factors of 64. Here are all the factors of 124. And the very biggest one that they have in common is the greatest common factor. Okay, and we worked on that in class almost all week last week. Now we are going to least common multiple. Least common multiple means multiples that are shared by 2 or more numbers. Okay, they're called common multiples. The least common of the multiples is called the least common multiple, LCM. You can find the LCM of 2 or more numbers by lists or factor trees. Same exact 2 ways we could find GCFs, right? Okay, but we have to remember the difference between factors and multiples. So let me have you guys get your pencils ready for your notes. Are your pencils ready? Okay. Or a brand new page, whichever you want to do it on. Okay, on your notes, I'd like you to go ahead and draw a big, fat F. Okay, above that F, write the word factors. Okay, and for this factor F, I'm going to put the factors of 18 in pairs. So the factor pairs for 18 are 1 times 18, 2 times 9, 3 times 6. Are there any more factor pairs? Nope. And are we talking about prime factors or just factors?
Just factors.
Factors. Very good. Okay. The other thing we're going to talk about are multiples. Yep, you're going to keep writing. And you're going to make a big fat M. Okay. Multiples of 18 would be 18, which was 18 times 1. 18 times 2 is 36. 18 times 3 is 54. And we could keep going and going and going on to infinity, couldn't we? Those are multiples of 18. So if you're looking at a multiplication chart, basically what that chart is are all the multiples of each of those numbers in each of those rows and columns. Okay? So if you look at the threes row, you see 3, 6, 9, 12, 15, 18, 21, 24, and so on. Those are lists of multiples in an array, basically. Yes.
So I know you probably already said this, but like, is the main or like, is the difference just that they're? I don't get what the difference.
Factors are the numbers that build. What numbers is 18 built from? Those are factors. Okay? And multiples are what can you build with that number times another number. So what can you build?
36.
So you can multiply 18 times 1, 18 times 2, 18 times 3, and you would think about a good place to find multiples is on your times table chart. Okay? Those are great lists of multiples. Okay? Factor pairs are what the number itself is built from. Multiples are what you can build with those numbers. Think of your times table charts. Okay? And so least common multiple, what we're talking about today, the least common multiple is multiples that are shared by 2 or more numbers. So finding the least common multiple of 4 and 6, here's an example of how to do it. By listing. Here's all my multiples of 4. If I look on my multiplication chart, those would be the numbers listed. We probably have more because our lists are bigger than just up to 48 and 36. Okay, those are the multiples of 4 and 6. Notice there's some common multiples, don't they? But do you suppose the smallest one is the least common multiple? Yes. It's the first multiple both numbers have in common. That's what a least common multiple is. In this case, they have 12 in common, and it's the first number they both have in common. Okay?
Got it. Wait, so for
You can also use prime factorization to find least common multiples. Same two numbers, a 6 and a 4. Here's my prime factorization for 6. Here's my prime factorization for 4. And then you ask two important questions. First of all, what numbers appear in the prime factorizations? 2s and 3s. And then you ask what is the greatest number of time each appear in any one prime factorization. So which one of these has the most 2s? 4 does. There's 2 of them. Which one has the most 3s? 6. But there's only 1. So what you will do then is you will take the amount of numbers that appear the most. Since there were 2 2s in 4, you use 2 2s to solve and only 1 3. And then you take and you multiply them back together like we did for GCF. Okay? So what numbers appeared? 2s and 3s. How many times does each number appear in any one prime factorization? 3 only happened once over here, but 2s happened twice in this guy's prime factorization. So you multiply 2 times 2 times 3 to get 12. Same exact answer. Okay? Here is the list method for 12 and 18. You can list all the multiples of 12, all the multiples of 18 until you find the smallest number they both have in common. Okay? Or you can build these factor trees, right? 2 times 2 times 3 is what 12 is built from. 2 times 3 times 3 is what 18 is built from. Then you ask the question, what multiples appear? Well, 2s and 3s appear. Which one of these has the most 2s? The 12 does. And there are 2 of them. So I take 2 2s and I put them here. Which of them had the most 3s in the prime factorization? 18 did. So I put 2 3s here. And then I just multiply it all back together to get 36. Notice how my answer is 36 here for the list version. And I get the same exact answer using prime factorizations. Michael.
So it's basically just a regular factor tree, but the multiplication is different?
The multiplication is different in that you have to ask those two important questions, which you are now going to put into your math notebooks. These two questions. What numbers appear is the first question. So put that in your notes. And then the second question is, what is the greatest number of times each appear in any one prime factorization? So please copy those two questions into your notes. Mind you, I put a period here and there should be a question mark. That bugs me. I'll fix it later. Okay, so right now you should be writing these questions in your math notebook. Question number 1, what numbers appear? Question number 2. Question number 2 is, what is the greatest number of times each appear in any one prime factorization? And you're going to notice in your 1.5 notes, they showed you the factor pair method, listing the factors. And then they also showed you the multiples, listing all the multiples. And then they showed you the factor tree method. Yes.
Is it possible for like this way, that there could be all 4 of the same numbers or as many as the same numbers?
Yeah, I think what you're saying is there a possibility that both numbers could have, each of them have 3 2's in it?
Yeah.
Yeah.
2, 2,
Or-
2, 2.
Yeah, so if they both have the same number and that's the maximum amount, that's how many you use.
So you just multiply it by 4?
No,
Just,
if for some reason one of the prime factorizations has 3 2's in it, and the other prime factorization also has 3 2's in it, since that's the most it appeared in either one, you put 3 2's back into your multiplication problem to solve it. Okay, so if they have 3 2's in both of them, and then maybe a 7 and a 4, or a 7 and a 5, then you'd go 2 times 2 times 2 times 7 times 5, assuming that the 7 and the 5 only happened once in the prime factorizations. Yes.
If we're listing like the multiples on the list, can we just go till we get least?
Yep, you just go until you get a least common multiple. Has everybody written those questions down?
No.
Okay,
You said no.
so
Karen?
I'm going to switch back over to my whatcha-dinger here.
So what's my thing?
Okay, on my Jamboard, I'm going to do an example problem. Please don't do anything, just watch. Okay, I'm using the factor tree method to start. All right, the two numbers I can think of right away that build an 18 are 6 times 3, and then a 2 times a 3. Then 9 times 5 build 45, and a 3 times a 3. So my prime factorization for 18 is 2 times 3 times 3. My prime factorization for 45 is 3 times 3 times 5. My first question is, what numbers appear in the prime factorizations? There are 2's, there are 3's, and there are 5's. Which one had the most 2's in it?
18.
18, but there was only one. So that's the only amount of 2's I'm going to put down there. Which one had the most 3's in it?
40.
Tied. They're tied.
They're tied. So we have to have that number of them in there. They both had 2. Which one had the most 5's? 45 did, but there was only one, so I can only put one back in down here. Now I multiply all this together to get the LCM. Well, what's 2 times 3 times 3? It's 12, right?
Yeah.
Wait.
18.
18, I lied. 2 times 3 times 3 would really be 9 times 2, which is 18. And then I have to take that 18 and multiply it by 5. Five times 1 is 5, plus 4 more. Okay, So 90 would be the first multiple they both have in common. Their least common multiple is 90. Okay? Can you do the list method as well?
Yes, you can.
So the list method for those two numbers would look like this. For 18, it would be 18, 36, 54, 72, and then 90, right? But for 45, 45 times 1 is 45, 45 times 2 is 90. So can you see that's the first time they have the multiple 90? Is the first time they have a multiple in common.
Yeah.
Okay, so there's those two methods. You can do the factor tree method and ask the two questions. Or you could list them just like we listed to find greatest common factors. But in this case, you're listing multiples, not factors. Yes, Michael?
I feel like that one would be a lot faster and easier to do.
Which one?
The tree one.
The factor trees end up becoming pretty quick compared to listing factors because sometimes, or multiples, because sometimes it takes quite a few multiples before you find them that have something in common. I want to go back to this example list over here. I want to look at this list right here, 11 and 12, and I want to talk about it just a little bit. So if I have the prime factor 11, or if I have to find the least common multiple of 11 and 12, can I make a tree for 11? No. So then why bother making a tree for 12? If one of the numbers that you're looking for the least common multiple of is prime, just multiply those two numbers together automatically. Because you know that 11 is only going to appear once here. That's not going to have any other factors. And you know that no matter what the factors are over here, you're going to have to multiply them back together again anyways. So it would be 2 times 2 times 3 times 11, which basically is those two numbers multiplied to one another. So the LCM is just the two numbers multiplied to one another. So if you happen to have one that you can't make a tree for because it's prime, multiply it to the other number. That's going to be your least common multiple. Okay? Don't make the trees for both of them because you can't make a tree for one of them. So you might as well not make the tree for the other one. Just default to multiplying them to each other. Make sense?
Yeah.
Okay, on your homework assignment, you will be told, okay, find the least common multiple. Okay? And then it will say by using the list method or by using factor trees, prime factorization. So you need to pay attention to that. We have plenty of time left in class to work on those only 9 questions for homework tonight. Okay? Shh. Sit down. I'm not done giving directions. Okay? You have time right now to either log in and finish up the work that's on the Google Classroom. Okay? That assignment that I gave on Friday. If you're not done with that, you have time right now to log into a Chromebook, work on that, or you could just do the homework that's due for tomorrow out of the book, okay? So that's your choice. If you choose to do the Chromebook thing, yes, you may use headphones. If you rather do your math homework out of your math book first and still want to listen to music, then you still can take a Chromebook. Just don't knock everything off your desk while you're working. Questions? Michael had a couple.
I was going to ask that.
Oh.
I was going to say, well, what I was going to say, because you just said that we could listen to music while working on videos.
Or that other, yeah.
But I was just going to say, since we already have the computer out, and you told us that there's a way to get on the math book for free on the computer.
Yeah, use that method. Yeah.
Then you don't have to do the classes.
Right. So you can always go here and watch that video about how to get to your math book live. I'm going to show you how to access your
Sounds like music to my ears.
Yeah, bring me your plan.
It sounds like music to my ears.
You might have to use, I think they're changing that one little boy who has to use like the changing table. So you might have to go downstairs or upstairs to a girl's bathroom, okay? It's just if that door is locked, go either upstairs or downstairs, okay? You can't unless you bring your planner. Okay, like I told her, I think they might be in there using that changing table. So if the door's locked, go either upstairs or downstairs.
They showed us the downstairs and upstairs bathrooms, I think. Yeah, they did.
Yeah.
I guess I don't need those papers that are there that fell out a while ago, but these already filled out.
I'm going to go. You can't control me for I'm a crazy wild horse. A whore? I didn't mean that. I meant whore. Is that us? No, it's not us.